Okay, so we were discussing this question over here, and we said that we can even use the uh, wait. Yeah, so we were discussing this question over here, and we changed the interest rate to 12%. We said we can even use this formula, or we can use the annuity formula as well. Both will give us the same answer. Now, just to make you understand what the annuity formula is doing for US. So these are your cash flows, and you have this 1000 over here as well. So this part of the formula, it calculates the present value of all of these hundreds, the equal cash flow stream that is coming every year, and you know it will end in 5 years. So it fulfills all three criteria of annuity. And when you apply this formula, it calculates the present value of all of these hundreds together. So now you are just left with this 1000 cash flow. You need to bring this back 5 years as well. In order to do that, you will just discount this back using the single cash flow formula. So you're actually doing this step but with 1000 only now. So you will use the single cash flow formula over here, and you will bring it back 5 years. So actually this question has this formula has two parts to it. One is the annuity formula, that is for the equal coupon payments, and the other is for the par value, which is a single cash flow. So if you use both formulas and you add their answer, you will still get the same answer. Now you can calculate this using another interest rate as well. So now we have assumed that the market interest rate is 10%. Again, you can use both formulas. This formula is giving you an answer of 1000, and the other formula is also giving you an answer of 1000. So whenever the coupon rate and the market interest rate are equal, whenever these two are equal, the bond will trade at par. Neither will it trade at premium, neither will it trade at discount, it will trade at par value. So if you look at all three answers in table, from here you can see that when the discount rate, the market interest rate goes down, the price tends to go up. And when the market interest rate goes up, the price tends to decrease. And when both of them are equal, only then the bond will trade at its par value. So from here you can see that bond have an inverse relationship. You can see from here that the bond price and the discount rate, the market interest rate, both of them have an inverse relationship, a negative relationship. That is, whenever one thing will go up, the other will for sure go down. So if the discount rate decreases, the price will go up. And if the discount rate increases, the price will go down. This is also seen from the formula itself. If we go back to the formula, you can see over here, if the R increases, automatically the price will go down, because the formula is in such a way. Even over here, if the R increases, the price will go down, and vice versa for the other way. Then we did this practice exercise, so you can do it later on as well, and the solutions are here. So the one that has a price less than 1000 is a discount bond, and this one is a premium bond. Okay, bond value with different compounding periods. So a bond that matures in 4 years has a par value of 1000 and an annual coupon of 7% paid semi-annually. Usually your bonds have semi-annual payments. Okay, So your question will mention if it is semi-annual, but usually bonds have semi-annual payments. The market interest rate is 8%, and what is its price? So now you do not have annual payments, instead you have semi-annual payments. So you will have to do two steps once again. One is to divide the interest rate, and number two is to multiply the n by the compounding periods. But you have to be careful that over here you don't have just one interest rate, you actually have two interest rates. So you will have to do this step two times. Okay, a bond that matures in 4 years, so n over here is 4. It has a par value of 1000 and an annual coupon of 7%. This is your coupon rate, 7%, and the market interest rate is 8%. It's semi-annual, so the compounding period m will be 2. So n will be multiplied by 2. 8 is your new n. 7% will be divided by 2, so 3.5% is the new coupon rate, and market interest rate will also be divided by by 2. So this will be 4%. So these are the values that you will now use. The steps will still remain the same. So now the coupon rate is 3.5%. That means the coupon payment is now 3.5% times 1000. So the coupon payment is now 35. And the R is now 4%, so we have 4% in place of R, and N is 8, so we have 8 at both places. The par value is still fixed, it's 1000. So if you calculate this, the answer is coming 966.34. You can do it from the annuity formula and you can do it from the single cash flow formula as well, but you can see from the single cash flow formula it is quite long, because now 4 payments have actually translated into 8 payments. So you will have to do it 8 times. The first coupon payment is 35, second coupon payment, third, fourth, fifth, sixth, seventh, 8, because your n is 8 now. Okay, so both of them will still give you the same answer, but the annuity formula is more easy and more convenient to do, and this is the formula that you should use from now onwards for all of your calculations. Okay, so whenever you have different compounding periods, make sure you do follow these two steps. One is to divide the interest rate by the compounding period, and number two is to multiply the n by the compounding period. And do not forget that there are two interest rates over here, so the coupon rate has to be divided and the discount rate also has to be divided by m.